Good morning, everyone. We're going to be talking about circles today. This is the beginning of Unit 4. And so today our focus is arcs and central angles. Our central question, how do we use arcs and angles to find missing values in circles? And our two learning targets, which yes, you need to write down both of these. I can define and use proper notation for circles and their parts. And our second one, I can apply the relationship between central angles and radii to find the angle measures. All right, so let's go ahead and get started. We are going to be using colors today, so if you have not picked up some colors, then please grab them. This first one, you should see this drawing or this picture on your page here, and you're going to need to title it. So above the picture, if you will write minor arc, and I would write that in red, hence the boxing of red because mine's already written. And so we're going to be talking about what a minor arc is. So within a circle, a minor arc, we're going to write this right underneath, is any arc that is between 0 degrees and 180 degrees. So something to keep in mind, I'll remind us right now, is that a circle has 360 degrees to go all the way around that circle. So 180 degrees would basically be half a circle. We'll get there in a minute to talk more about that. So in this case, an arc that is between 0 and 180 degrees on your picture, if you will trace from A to B along that circle's edge, that is what we would call arc AB. And we write it like this, AB, and then we write a little curvy thing on top. So that would be arc AB. Let me write that one more time for us. There we go, arc AB. And I'm going to write that in here. The measure of arc AB is between 0 and 180 degrees. One other thing I want to make sure we understand for minor arcs is that we use two letters to name it. So minor arcs are the only arcs that we can use two letters to name. And again, they have to be small arcs, less than half a circle. Let's go to the next one, major arc. This one we're going to do in green. So grab your green. And I'm going to, once again, outline. I would write this in green, but since mine's already written, I'm just going to outline it or box it here. So I have major arc in green. And my major arc in this picture, actually, we'll start with the measurements. Major arcs are between 180 and 360 degrees. So they're bigger than half a circle, but smaller than a whole circle. In this case, we're going to go ahead and trace from point A to point B, but instead of going the short path to do a minor arc, we're going to go a long path, which goes from A to D, and we keep going all the way around to B. And that would be a major arc. It's bigger than half a circle. And for this one, I'm going to call that arc that we just labeled, not M, excuse me. We're going to call that arc by the letters where it starts and stops. But also with a major arc, we're going to end up using three letters to force us to go the long way around the circle. So if I just say AB, it's not clear if I go to the left or if I go to the right, if I do the big arc or the little arc. So major arcs will use three letters. So this is going to be arc A, D, B. Or I could have written it as B, D, A, so I could reverse the order of the letters. The same with the minor arc. But a major arc, we have to have the three letters. It tells us we have to go the long way around. So here I would say the measure of arc A, D, B, and again, that nice curvy thing on top. And we're going to make that note as well that here for a major arc, we're going to use three letters to name it. All right, so get that caught up, and then we are going on to our next one. And for the next one, whoopsie, well, there you go. We're going to use blue. So grab that blue. And here we go for a semicircle. Go ahead and write this in blue. There we go. And for this one, a semicircle, just like it sounds, hopefully semi meaning half. This is going to be exactly half of a circle. And so when we name a semicircle, it's a lot like a major arc. We're going to go from point A to point B, but we are going to specify that we're going through point D as well. If I say just A to B, it sounds like a minor arc, and semicircles are definitely not minor arcs. They're also not major arcs, but we follow that pattern like we do a major arc. So this would be arc A, D, B. And we would say the measure of arc A, D, B equals exactly 180. So a semicircle has to be exactly 180 degrees. Other things to note that I mentioned, we're going to use 3 letters, like a major arc, to name it. And then the other thing is that a semicircle, the arc itself must begin and end on the endpoints of a diameter. So hopefully we remember from previous math classes, a diameter is a line segment that passes through the center. So we have that center at point C, and we see our line segment passes through the center and has endpoints on the actual edge of the circle. So point A is on the circle, point B is on the circle, and passes through the center. So there we have a diameter. Also, a quick heads up, because we are going to see this in a minute, a radius would be half of a diameter. A radius goes from that center point to the edge of the circle. So from C to B would be a radius, or C to A would be a radius. And we'll talk more about those coming soon. All right, so we've seen 3 new figures. We have 2 more to go, 2 more things to talk about. So let's go ahead and keep moving forward. The next thing we have is something called arc addition postulate. We're going to need red and green for this. So grab your red, and we're going to write some things about this. So I'm going to start with A and D, and I'm going to trace the arc. And then I'm going to grab my green, and my green is going to be D to B, like so. I'm going to go back to red and say, hey, guess what? AD, arc AD, which is a minor arc. Notice only 2 letters. And I'm going to grab, actually, while I'm here, I'm going to go ahead below this, give yourself just a little bit of space, and I'm going to say the measure of arc AD, because we're going to write 2 things here. All right, so I'm going to switch to green for a minute. Give yourself a little bit of space, because we're going to write the word and in there. And I'm going to say DB, arc DB. And down here, I'm going to say measure of arc DB. And then I'll grab my regular writing utensil and whoopsie. And we're going to say, okay, for this first sentence, arc AD and arc DB are adjacent. And I'm going to spell adjacent correctly. That would help. And also review with us. We've seen that word pop up a few times before. And just a reminder, adjacent means next to. So these 2 arcs are adjacent or next to each other. And then the second thing we're going to write down here with the measure business is the measure of arc AD plus the measure of arc DB. When I add them together is going to equal, and I'm going to grab a third color, grab your blue, and I'm going to say it's equal to the measure of arc ADB. So basically, if I take the 2 parts, the red and the green, and I add them together, it's going to equal the entire arc. This hopefully seems pretty straightforward for us there. All right, let's go on to the last of our circles to fill in here. The last one we have is central angle, and this one is going to be super important to us. Central angle, I'm going to go back to red, and I'm going to write this in red, or have you guys box it or write it in red. Central angle. Central angle is a situation that looks like this, where I have a vertex of an angle at the center. So there's my center C. In fact, I'm going to write that down. The vertex of the angle is on the center. It's really important. So vertex of the angle is literally right on top of the center of the circle. Awesome. Okay. And then I'm going to say, okay, so then we're going to talk about the measure of angle C, which we'll get to that in just a moment. But first, in my picture, I want us to be reminded about these two segments here. I talked about them a moment ago. A segment from the center to the outside or to the edge of the circle, we call that a radius. And this one as well, I'm going to try to write it sideways. So far, so good. Radius. Okay, so we have a radius and a radius. A central angle is an angle that is formed by two radii. That means it's plural for radius. So I have a radius and a radius, and I have this angle right in here that's formed by them. And there's a special property for central angles. The measure of the angle, so measure of angle C, is going to equal, and this I'm going to just do in my regular writing utensil, is going to equal, then let's grab blue, and I'm going to identify the arc. Here I have arc AB. That is the arc formed by the two radii. So measure of angle C is actually going to equal the measure of arc AB. So the angle and the arc are going to be matchy-matchy. And that's going to be really important for us as we continue forward. All right, so with all of that, let's go to some examples. Examples 1 through 6 use circle C given below. When we name a circle, we name it by the center. So this is telling us that C is in the center. Then we have segment AE is a diameter, so passes through the center. And we have the measure of arc AD is 42 degrees. So I'm going to go ahead and put that on my picture right now. The measure of, and I'm just using purple as kind of my regular utensil, even though I was using black before, but that's okay. 42 degrees. And the measure of arc BE is, so this one up here, both minor arcs is 20 degrees. Awesome. All right. So example 1, name a major arc. So there's lots of arcs you could give as a major arc. Remember that a major arc must be more than 180 degrees. So my diameter here, I've got to go past that diameter on one of the sides. So one option for this, and I'm going to do this one in red, is that I could do something like this. I could start at A, and I could go from A all the way around. I can't stop at B because I haven't passed halfway. Here's halfway, but I have to go past that to get a major arc. So I'm going to go all the way to D. That would be a major arc. And so I would call this A. You can choose either B or E to be your middle letter. I'm going to say B, but my third letter must be the D. So the first and the last have to be your start and stop. I could do it in reverse order. So I could do this, or I could say D, B, A. And again, you could have used E instead of B if you wanted to. All right, name a minor arc. On this one, I'm going to go ahead and pick green.
Mrs. Laverne Williams, please call extension 202. Mrs. Laverne Williams, please call extension 202.
All right, with my green, I'm just going to remind us we have some minor arcs here. Actually, I'm going to choose one that isn't already highlighted. I'm going to go from E to D. That is a minor arc. It's less than half a circle. And so I'm going to call that ED. Or again, you could call it DE. All right, to name a semicircle, in this one I can go either direction. I'm going to use blue here. I could go around the bottom or around the top, but I have to, the only diameter I have is AE. So those are going to be my endpoints, A and E. And then I can choose which side of the circle I want. I'm going to go ahead and choose the top. So I'm going to go around the top like so, all the way around to E. And to name that then, my middle letter, I have to use B. So A, B, E, semicircle A, B, E. All right, let's continue forward. Number 4, and I did all that fabulous work. I'm going to copy my setup here that AD is, what was it? Measure of arc AD is 42 degrees and arc BE is 20 degrees. All right, this one says find the measure of arc DE. Well, if I look at this one, arc DE, I'm going to go ahead and go back to red here. Arc DE is this one right here. And we're going to use some arc addition postulate business here. If I happen to notice that, again, my diameter is right here, which cuts my circle in half, I know this half of the circle has to be 180 degrees. And I have this piece right here is 42. To find the missing piece, I can do 180 minus the 42 degrees I know. And that will give me, let's see, I believe that will give me 138. So the measure of arc DE, whoopsie, not DD, DE equals 138 degrees. Cool. All right. Let's take a look at the next one, example 5. This one I'll do it in green. We want arc AB. So this time I'm going from A to B. Going to use that arc addition postulate again, using my diameter to help me out. I know that the top half of that circle has to be 180 degrees, and I have 20 degrees. So once again, I can say I know the total is 180, and I'm going to subtract the 20 degrees that I have, and that's going to give me 160. So the measure of arc AB is going to equal 160 degrees. Awesome. All right, so on to example 6. And for example 6, let's use blue. Okay, so this one asks us for arc AEB. So from A to E to B. So A to E, almost to E, a little bit further to B. Cool. I'm going to get rid of this. There we go. A to E to B. Now here's the thing. We have already done some work to figure out some of the arc pieces. We know this one is 42, that one is 20, and this one we found is 138. So I can use my arc addition postulate and basically add those together. I know a piece of it is 42 degrees. The next piece is 138, and the final piece is 20. So I'm going to add all of these together. And I see, let's see, 2 plus 8 is 10, 0, carry the 1, 1 and 4 is 5, plus another 5, that's 0, carry the 1. It looks like I get 200 degrees. So the measure of arc AEB equals 200 degrees. All right, our last 2 examples. Let's take a look. Example 7, in circle R, so R is the center. The measure of angle QRS. So Q to R to S. That's this angle here with a vertex at the radius. I'm sorry, at the center. We have 37 degrees. Ooh, 37. And we are supposed to find the measure of arc QS. So we're asked how many degrees is arc QS. Since this angle here is a central angle because it has a vertex at the center, then the arc and the angle will match. So we can say the measure of arc QS equals 37 degrees. Next one, in circle L, so L is the center, we have the measure of arc KM. So this arc right here, KM is 56 degrees. And we are asked to find the measure of angle KLM. So this angle right here, we're asked to find what is the measure of that angle. And once again, this angle is a central angle because the vertex is at the center. So central angle and arc are going to match. So this would be 56 degrees as well. So I can say the measure of angle KLM equals 56 degrees. And that finishes our notes. Please check Google Classroom for your assignment. All right, we'll see you guys later.